Okay, we will solve the final exercise of the first part of the book, Engineering Mechanics by Bedford. The exercise is the 1.21. It actually is telling me the equation, which is this one, is used in the mechanics of materials to determine normal stress in beams. To determine normal stresses in beams. A. When this equation is expressed in terms of international system-based units, M is in Newton meters, Y is in meters, and I is in meters to the fourth power. What are the international systems units of sigma? B. If M is equal to 2000 Newton meters, Y is equal to 0.1 meters, and I is equal to 7 times 10 to the minus 5th power meters to the 4th power, what is the value of sigma in US customary base units? Well, the principal thing that we have to recognize here is that we are talking about an stress. And stress by definition is given by a force divided by an area. Which area? The transversal area. Which force? The perpendicular to the transversal area. Alright, so this maybe we're going to solve some of the exercises that uses this equation using maybe some different shapes, but right now I think that the book might want to give like an introduction to this topic. So what we have to know here is that sigma is equal to my m times y divided by I, excuse me, and the units are Newton meter multiplied by meters divided by meters to the fourth power. Then the first question is, what are the international system units of sigma? Alright then I just have to play with these meters, which are the principal unit that are actually repeating itself. Then I'm going to eliminate these meters and these meters with two of the meters that I have right here. So the result will be in newtons divided by square meters. As I just said, sigma is equal to a force divided by an area, and a force in international system units is given in newtons and an area is given in square meters. So this is the final answer for the first part of the exercise. Then the second part of the exercise is if M is equal to 2000 Newton meter, Y is equal to 0.1 meters, and I is equal to 7 times 10 to the minus 5th power meters to the 4th power. What is this value of sigma in US customary base units? So the base customary base units, first we have to make that clear, is to change the newtons into force pounds and the meters into square feet. So remember this, when we're talking about a mass unit in international system units, we will have to talk about kilograms. And in US customary base units, base units, then we could talk about a slug or a pound. Alright, it is pretty normal for us to change units between these two. It's not that normal to change these kinds of units. Why is that? Because a slug is not that very common, but a pound it is. In international system units, it's more like easy to make a difference between mass units and force units, which are the newtons. But for the international system unit, for the US customary base units, we will have force pounds. Alright, so it is important for us to understand if I'm talking about a force pound or just a pound, talking about mass units. In the international system units, we also have something called the force kilograms, but I'm not going to get into that topic because it is not as important as it is managing this kind of information right now. Then I am going to now that I've made that clear, we could solve this exercise without any trouble. First, I'm going to find the result in international system units. So sigma is equal to 2000 times 0.1 divided by 7 times 10 to the minus 5th power. I'm going to write down that here. I'm sorry, this is not about the current exercise. This is about the previous exercise that I was solving. Then 2000 I missed a 0. 2000 divided by 7 times 10 to the minus 5th power, and that 2000 is multiplied by 0.1. The result is this one. I'm going to write it down using scientific notation, which is 2.8571. I always use 4 significant digits after the point, times 10 to the 6th power. Newtons per square meter. Then I gotta change this, as I said, I gotta change these kinds of units into force pounds divided by square feet. How can I do this? Well, there is an easy way and a long way, but the long way will give us a lot of information. The easy way is to go to Google. I'm gonna write it actually. To Google, type Newton to force pound, find an equivalence, which no, I don't know, maybe it could be X. Let's call it X. Then find the equivalence between meters into feet, square meters into feet. I'm gonna call it I don't know, H. And then 2.8571 times 10 to the minus times 10 to the 6th power. And then using this information, I'm going to write down here newtons into force pounds and find the equivalence between those two, which is this one. Maybe, I don't know, 1 Newton is equal to X. amount of force pound. And the same thing goes for the second part, which is square meters and square feet. So 1 square meter is equal to h quantity of square feet. And then I just have to put this equation on the calculator, and that is going to give me the final result. Or maybe I haven't tried that yet. I am complicating myself too much, because I could Google just Newton per square meter to force pound to divided by square feet, and maybe Google will give me the answer, or maybe it will suggest some calculator or something like that, and I just have to write down this, and the calculator will give me the answer, the final answer. But because of this channel is created for me to like remember some basics of maths and physics, and not just for me but for you to understand it, I'm going to use the long way, which is described in newtons in some different types of in some different kind of units that we can understand better and change the unit system. So, as I just said, I'm going to describe the newtons in a different type of units, which are more like easier. So a newton is equal to a kilogram multiplied by a mass divided by a square seconds. I'm sorry, I'm confusing it right now. No, a newton is a force, right? A force, because of Newton's second law, is equal to a mass multiplied by an acceleration. So a mass in international system units will take the name of kilograms, and an acceleration in international system units will take the name of meters per square second. I'm sorry for the first part, I was a little confused in my mind, but now I've made that clear. Then I'm gonna change that into force pounds. So when we're talking about a mass in use customary units, then we're going to talk about a slug, and the length unit for the use customary base units are the feet, and the seconds are the seconds. That is not negotiable. So, but I just do not have just the newtons. I have the newtons divided by square meters, so I gotta write down that here, and I gotta change the system of units. Then I'm going to play here with this equation. Imagine that I have a division for the square meters, and that division is the 1, because that doesn't change a thing. And I'm going to use the law in which I'm going to multiply the denominator part of the first division by the numerator of the second part of the division, and the same thing with the numerator of the first part and the denominator of the second part, and the result will be kilograms per meters divided by square meters per square seconds. And then I could eliminate, I'm gonna eliminate these meters with this squared. So this result will be in kilograms divided by meters per square seconds. So as you can see, this is the same thing as this. Alright, now changing the system of units, I'm going to transform those into slugs divided by feet times square seconds. Alright, now for me to do this, I gotta memorize some different equivalences. So let me write the value that I gotta transform from. 85, 31, 71 times 10 to the 6th power kilograms divided by meter per times square seconds. And then I'm going to eliminate the kilograms, transform those into slugs, and finally I'm going to eliminate the meters and transform those into feet. Why am I putting the slugs on the upper side of the division? Well, this is because I have the slugs, I have the kilograms on the upper side of the division of the units, which is this one. And by multiplicating a division in which the kilograms are on the below part of the division, I could eliminate those. And I actually going to do it. I'm gonna do it. Kilograms, and meters. The same explanation goes for the meters. Then I just gotta write down the equivalence between these two. So this is by memorizing it. 1 slug is equal to 14.59 kilograms. And 1 meter is equal to 3.281 feet. And that's it. That is all I got to do by just changing the system of units. Then I gotta write down that on the calculator. So answer is equal to the answer that I had before. So answer multiplied, divided by 14.59 times 3.281. I know that this is pretty easy for some of you, but others may get confused with this notation that I'm using on the calculator. So remember that when we are talking about a multiplication by 1, is going to be the same number. And I just gotta multiply by 1 and again by 1. So this is the same number. And I have these two numbers on the denominator part of the divisions. So I just gotta multiply those numbers. And the result, I gotta divide it. Well, I actually gotta divide this result by the multiplication of these two numbers. Alright? That is why I'm actually using this kind of notation. So the final result is 59.6857. I always use 4 significant digits after the point, times 10 to the 3rd power, and units are in slugs, divided by feet times square seconds. Or this is the same thing as having force pounds divided by square feet. Alright, so this is, guys, the final answer for this exercise, and that's how this exercise could be solved.